So before we start, does anyone have any questions about yesterday's assignment, yesterday's exercises, about the assignment? Have you started? Is there something stopping you, or so on? Yep, a question over there.
Yeah, as I asked, yeah, this morning you can elaborate again about teleports and the reserve withdraw.
Sure. Okay, so teleports and reserve transfers. Let me go back maybe to this slide and do a little recap. I think it's yeah, transfers. Okay, so we have two ways of doing cross-chain transfers. So when you do a normal withdraw, like the withdraw asset instruction, it will withdraw from wherever you are. So whatever chain is executing it, it will withdraw from some account in there. So that's local. That's just some local withdraw. You could, for example, send a message that just says withdraw and deposit, and it will be like remotely controlling some accounts, but you wouldn't do the cross-chain transfer stuff. For doing a cross-chain transfer, you either do a teleport or a reserve asset transfer. I think I can move them like this. Yeah. So the teleport is the simplest one, and it's just burn and mint. But this is just about how it works. Well, you have to know how it works. But at the end of the day, you can only use teleports in some scenarios, and you can only use reserve asset transfers in other scenarios. So basically, teleports you can only use between system chains for DOT. So DOT for system chains, or West End, or Paseo, or KSM. You can use on the system chains. And you can use if a parachain registered their token as a foreign asset on Asset Hub, you can teleport it back and forth between that particular chain and Asset Hub. Those are the two cases where you use teleports. For the rest, you use this reserve asset transfers, where there can be 3 chains involved or just 2. So if there are 3 chains involved, you can imagine, like, I don't know, 2 parachains. We can mention some we've mentioned so far, like, I don't know, hydration and hyperbridge or something. And say these 2 want to send, or hydration wants to send some USDT to hyperbridge. USDT is not native to neither of them. The reserve for USDT is Asset Hub. So the one where USDT exists, where Tether, for example, minted USDT, issued USDT, that is Asset Hub, which would be the reserve, the chain R. So in order for A to communicate to B, in order for example, hydration to communicate to hyperbridge and send the USDT, it has to send a reserve withdraw to the reserve, and then it has to do a reserve deposit to B. So reserve withdraw and reserve deposit depend on whether the sender or the receiver is the reserve. And those are one of the 3 options that you have, 2 of the 3 options that you have on the initiate transfer instruction. So whenever you're communicating with a reserve, you do reserve withdraw. Whenever it's the other way around, you are the reserve and you're communicating to someone else, it's a reserve deposit. What that does is the chain R has 2 sovereign accounts, one for A, one for B. Whenever A tells it to do a reserve withdraw, it will withdraw from its sovereign account. And then it will, of course, have a nested message, right? So you send only one message from A. That message will execute on R and then send another message to B, because it has a nested message. So the reserve withdraw takes money from the sovereign account of A, and then the reserve deposit deposits the money from one sovereign account, the one from A, to B's sovereign account, and then forwards a message to B telling it that it received some funds. So it's just all of the actual USDT accounts are on Asset Hub. All of the actual DOT accounts are on Asset Hub. With this system, chains can have their own account, just like users can have their own account. And you send messages to make sure that the chain has derivatives that map one-to-one with the actual thing that they have in their sovereign account. So just that was the recap. So you can you can use three things. You can either do a teleport, where they are equal, they're both like owners of the asset. That's why you only use it in very particular scenarios, between system chains for DOT, and between a native parachain token that has been registered on Asset Hub with Asset Hub. But then here, the chains are different. One might be the owner. So if you're, for example, one might be the owner and the other one might not. So it can be three chains. It can be also two chains if either A or B are the reserve as well. So for example, hydration has the HDX token. And if it wanted to send it to another parachain directly, it can. And then it would directly just do a reserve deposit, because each chain is a reserve for their own native token. There was a question over there, yeah.
So I'm still wrapping my head around sovereign accounts. So the native account is on chain R, but the sovereign accounts on chain A and B. Is that how it works?
Sorry, can you repeat that?
Accounts and sovereign accounts. I'm trying to understand where would the home account be? I don't know what's the correct word. So you have a sovereign account on claim on A and B in that transfer, and where is the when do you need the sovereign account on a chain? Is it because
we call them sovereign accounts, but like they're nothing special, they're nothing magical, they are accounts. But instead of being accounts that are controlled by a private key, just like Pallet owned accounts that you might have seen on the treasury assignment, for example, like the treasury is a Pallet owned account, like which create a public key, but there is no private key for it, right? It's exactly the same thing, but it's like a parachain owned account, or a location, like external location owned account. So it's just an account that of course lives, because it's an account, it lives somewhere. So in this case, it will live here, but any chain can like create accounts for another chain. We just call it a sovereign account because it represents another chain. So whenever they have tokens there, it means it's an account on control of another chain. So that another chain has control over that account, yeah. There's one at the back. It's gonna be hard to get the mic to him. Okay, good. And I think it's one at the front.
If I understand correctly, the sovereign account is just like a proxy account that could be maybe, so like the difference between like a 2-chain and a 3-chain reserve asset transfer would just be like, I guess the 2-chain would be like chain B has a sovereign account on chain A, and the third, like the 3-chain one, is both of those have a sovereign account on the third one.
Yeah, correct. So it's like a proxy for the chain, because it's easier to handle, like just at the end of the day, these cross-chain transfers have some action happen on the source chain, some action happen on the destination chain, and with the sovereign accounts, for example, in this case where there are 3 chains involved, in R we literally just move stuff from one account to another account, and that's it. And those accounts represent the chains, and then we just send messages to let them know that they received funds, so that they can have an appropriate mapping. Yeah, another question?
Like if you are a sovereign account versus like, let's just say that I made a different account on chain R, like is there some special guarantee that I
No. There's nothing special about the sovereign accounts other than the fact that they are how you create the account is via grabbing the location of a chain, for example, and then applying a function that will get you the account. So the only thing special is that when you do XCM and you reference a chain, it will know it's the sovereign account of the chain. But there's nothing special event-wise, or if you just look at a bunch of accounts, they will all be just like public keys and have some tokens. You would need to know what the sort of pre-image is to know that it's actually a sovereign account. So they're just accounts. We just want, so instead of having a Pallet-owned account, we just want a parachain-owned account. That's the only difference.
Is like burning or minting easier between sovereign accounts?
And then nothing is easier or harder, I guess. I mean, they're just regular accounts. Yeah, they're just regular accounts, but they can be controlled via XCM from the origin of another chain. So they're just regular accounts, just like a Pallet-owned account, but this chain can send messages and control it. But there's nothing easier or harder. They're just like, no one can sign on behalf of that account. The only way to access it is via chain A sending a message to chain R and telling it, hey, I want to do something with my sovereign account. So it's kind of like, it's a regular account, but the owner is, instead of a regular user, it's a chain itself. And then the chain might have like a pseudo key, and then yeah, it's just one guy controlling everything, or it might have a governance system that decides what to do with the sovereign account. Okay. It's owned by another chain. Okay, any other questions regarding sovereign accounts or cross-chain transfers? Yeah, one at the front.
There were two, I think, important slides. Well, they're all important, but that showed like the order of the build phases, the instructions of the build. I wanted to get, and they weren't on the other deck, so I just wanted to get a screenshot. Could you show those? One is instructions: withdraw, pay fees, initiate transfer.
This with the local one, yeah. So that's on the XCM execution.
Yeah.
This is what you do at the start.
Yeah. And then one at the receiving end.
Good.
Yeah. Thanks.
That's it? Okay. Nice. Okay, let's get started then with one little lecture on the XCM Pallet. So the XCM Pallet is the link between XCM and Frame, and it's how you integrate XCM in your chains. Yeah, basically, if you want to use XCM in your chains, now this is like the link between Frame and XCM. If you want to use XCM in your chains, it's enough to just include the XCM Pallet. And of course, as you already know, configure it, right? Like input what you need in its config trait, right? And then benchmark it, all Frame things. So XCM can be used directly interacting with the executor via writing XCMs. So we saw that like all our examples have been of that, that you can just create an XCM program with different instructions and just submit that to the chain. And if you looked at the examples, like the execution exercise or what I expect for the assignment, is to just create an XCM program and call execute. The other idea was, okay, if you want just one extrinsic, one call that can do some XCM logic, then you can just create a call that internally creates an XCM and thus execute. Like you can either have the XCM come from the outside world, from off-chain, or you can just have a call that is very simple, like has a very simple signature, and then in there do the XCM stuff. And we have originally, because we have very bad or non-existent front-end libraries to build XCM programs, we originally were just have like a lot of extrinsics, a lot of calls that would be like, I don't know, do a transfer, right? And do, yeah, it's basically for transfers. And do a teleport, do a reserve transfer, and so on. So if you see Pallet XCM, it will be filled with calls. There will be one called execute, which is the entry point for executing something locally. One called send, which is what you need to just send something without doing any work locally. If you don't need to send any money, you just send the message. You don't execute locally and initiate the transfer. And then the rest are just like transfer assets and limited reserve, reserve transfer assets, teleports, all of those things we're deprecating in favor of just doing execute now that we have good front-end libraries like Puppy, which is given on the other track, and Paraspell, which is just abstracts away all this, all the complexity of building XCM programs, and you can just say, hey, I want to transfer from asset hub Polkadot to hydration, and it will just do it for you. It will create the message for you and call execute for you, and everything will be good. So that's sort of the separation of concerns that we expect in order to have a good UX, but not compromise the, like not need to do all the work on the chain side. But the calls will still be there. They're just like much more restricted with what you can do. And because they're on chain, you cannot break them and so as easy. They do not upgrade as easy. Like it's very clunky to have all the logic on chain. It's better to have all the logic off chain for creating these messages. So that's why we're deprecating them, but they will still be there. But yeah, I expect all of you, I mean, if you can, to use the new way. Okay, so the XCM Pallet is the bridge between the XCVM subsystem and the frame subsystem. It allows us to interact with the executor directly and provide some useful extrinsics that we want people not to use that much now. So the most important things, I guess, are executing XCMs locally versus sending them to a different location. Then we do have some functions to do cross-consensus transfers or cross-chain transfers, which, again, we're kind of encouraging people to use this too, whenever they need to use XCM. Then we do have version negotiation, handling responses, and handle asset trapping, which are very core functionalities that the Pallet XCM provides, but they're not in the way of calls. They're provided by the Pallet. They're traits that the Pallet implements that are not calls that you can call from the outside world. You configure them and they help you do XCM. So executing XCM locally, the glue that changes all of this is like, yeah, someone from the outside world submits an extrinsic. There is an execute extrinsic with some particular XCM program. Then that reaches Pallet XCM, and it interacts with the XCM executor, all the things that we've been talking about yesterday. It interacts with the executor, it executes the thing, and then this returns back whether it was a success, and yeah, link between frame and XCM, right? That's how we link the two together. Then we have sending XCMs, which, of course, execution can result in a new message being sent, as I mentioned before. But this can be useful mainly for tasks, like for parachain tasks. The parachain doesn't do a cross-chain transfer. Like if it was the parachain route, it will probably do a send that just takes money from the sovereign account, for example. So send is another entry point. You can either do execute or send. Execute is like better for regular users doing transfers because they need to burn their token locally and then send. So it's a local execution that results in a message being sent. But send is another entry point that is useful mainly for management tasks. But we have both of them so that we can do anything. So some users submits the send extrinsic with some XCM program and some destination. Pallet XCM will deliver it via the XCM router, which is configured on the Pallet. The XCM router is also configured on the executor, and that's how initiate transfer can know where to send things. The XCM router will put the message in the message queue, in the corresponding message queue for example, a particular destination. Then there will be some way to move between these two things. For example, if it's no bridge, this path between parachain A and B would be an off-chain relayer, right? If it's a bridge. If it's HRMP, this would just be the collator or the validators doing the relaying. There has to be some relaying between one message queue to another. That's how the protocol works. So here we're talking a little bit about the protocol. And then from this message queue, we call directly the XCM executor of the other side. All of this message queue stuff, all of this transport stuff also happens with execute when you have like initiate transfer. And as you see, we directly call the executor. So even though Pallet XCM is the entry point for extrinsics, we have an internal system that receives the message. And when you receive the message, you directly call the executor. When you receive the message, you don't call the pallet again. So that's why fees, for example, are paid via XCM remotely. So when you send a message, in the remote message, you say you want to pay for fees, and that the fees are included in the message itself, because we don't use any extrinsics. So we don't use the transaction pool. We don't use transaction extensions. We don't use like pallets, let's say. We just use this processor, which is just kind of like triggered every time a message arrives. Good. So that's most of how you interact with XCM. Oh, there's a question down there. Let's answer questions about these two things.
Yeah, like I'm just like, it might be confusion or so. I want to make sure, I want to know like how the XCM executor will make sure that there is no malicious activity in parachain A. Let's assume like we are not using the asset hop here. So the asset, like it's another parachain. So because I was expecting like in parachain A, there is kind of like execution and like making sure, yeah, it happened, and then passing kind of like cryptographic proof or anything like this to chain B.
Yeah, so from the XCM level, you don't do the cryptographic proofs, but the transport protocol can. So for example, HRMP does check a bunch of things for like of these two chains that are interacting. The simplest of them all is that you cannot spoof an origin, right? Like the transport protocol will make sure that you cannot spoof an origin. And then, for example, Hyperbridge, yeah, just you need to prove that it was actually a message that was sent. But like the things that you prove, I mean, it depends what you mean with malicious activity. Like if someone puts in a malicious message, but it's a valid message, then everything, like the system cannot cryptographically prove that you didn't do anything malicious. What it can prove is that you put something in that is not a message, I don't know, some bytes that are corrupt and will probably fail to decode, that you cannot do. But for example, if there's an attack on parachain A, like a consensus, like a governance attack, and someone like, there's a governance system, but literally no one interacts with it. And so a guy just makes a referendum to like get all of the tokens, and then sends those tokens somewhere so that he can off-ramp and leave, then yeah, I mean, he can do that. And that's parachain A's fault. And parachain B doesn't mind if it's a valid message, because from the perspective of parachain B, everything is fine. Parachain A told it that it wants to do something.
Yeah, I mean, like, let's assume we have like a burn token in parachain A, and it's kind of like a fake burn, like nothing burned, and parachain B will.
Okay, wait. So you mean only with the transfers, like a cross-chain transfer? Yeah. So that all comes back again to the other slide. Let me repeat it. So here, you wouldn't do this. Again, this you only use in very particular scenarios where one of the two chains is the system. So here, you don't use this if you just have a random chain and interact with a random chain, okay? And then here, what you do, or for example, what you do if you're doing A and B, like there's no R, A is equal to R. This is the parachain native tokens example. This would be the example. Like you have, I don't know, Moonbeam, which has a glimmer, and wants to send it to hydration, which is just a chain. So Moonbeam is the reserve. So what it does is, there's no burning and minting like of the real asset. Like the real asset goes to the sovereign account, and then B is told to mint some derivatives. So If A is malicious, then of course B is screwed. But that's always like if someone creates a meme coin and you have all your savings on that meme coin, then you kind of, I mean, yeah.
That's exactly what my question. Like, there is no way, kind of like monitoring to make sure, like after this happened, like make sure that the entire process from chain A to chain B is all like it's secure and nothing malicious happens.
So the process is secure, but the tokenomics might not be might not be sane.
No, I mean like the code itself. Like, yeah, I have token and it's locked or burned, but actually it's not burned.
No. So okay, so you can always do the monitoring, but like you move the token to the sovereign account. You can check that it is in the sovereign account.
Who's checking? This is my question. Who's
Well-
checking that it's there? Is there a
Yeah,
way
so
to check that the lock happened and it's now in the sovereign account?
Yeah, I mean, always. You can
Who
always
is-
check.
Like, this is my question. Who is checking?
There has to be some like relayer or something that checks. So in the case of, I don't know if HRMP does this, but there has to be some off-chain process that checks it, because querying the chain, you cannot like query a chain from another chain. You usually use a relayer that gets the thing and uses
As a
storage
runtime
pool.
developer, I have to do this check or like automatically injected in the like the runtime.
No, I think you would have to do the check. Yeah, I mean, you would have to do the check, I believe. I mean, how do I say this? It's kind of easy to know that like if this doesn't hold. Yeah, I don't know that we do it. What is this? I don't know if we do it automatically, but it's very easy to know if there's a mismatch. And that's the whole idea. So, I mean, you can check if the sovereign account, yeah, if it is on your sovereign account. But the whole idea is that if B mints like 1 million derivatives, you don't care, because this is the source of truth. And you trust this chain because you trust the tokenomics, you trust the governance, you trust the things. Yeah. So even if you monitor, what do? You just stop dealing with that chain. Like you just empty your arcs of their token. Yep.
I think I want to acknowledge that that is a real concern, that you want to make sure that the safety of your chain does not depend on the meme coins coming from another chain, right? And this comes up in XCM in a bunch of ways, where like, oh, how do we do fee payment for assets coming in from other chains? Where like, yeah, we trust them to be a reserve of their own token, but like, what do we do with that token now? Because we don't know if it has value, right? And then what happens in the case of the asset hub and hydration and some others is that you have swaps built in, right? And you go like, okay, we have a market locally. We'll let the market decide, the market, the automated market maker or whatever, decide how much value it has. And otherwise we just fail the transaction execution.
Yeah, so everyone can create a token, and they are not necessarily all worthy. Most of them are worthless. And like, if there really is some value in the token, so for example, on Asset Hub, we say we kind of agree that the sufficient assets that are enough to cover your ED, for example, they are USDC, USDT, DOT, and ETH. So we assume those ones have inherent value and are enough to get your existential deposit, to count towards your existential deposit. And then we have swaps, and yeah, if there's a market and you can actually swap it for some other thing that is useful to you, then it has value and you can use it. But you cannot just like accept any token from any issuer, because parachains can be spawned by anyone, right? And that's the whole point. You can have, or parachains as sovereign entities. That's also why we can trust chains to be the reserve for their own token, because they are the issuers, but we cannot trust them to be a reserve for something else. And we don't even need to have a channel with them. So if there's a chain that has just spawned, it's quite suspicious. Like it has just only one developer, probably it has pseudo access, right? you don't want to depend too much on that chain. You can just not have a channel to that chain. And maybe if you want to interact with it, you can interact via Asset Hub. But also, you don't want to depend too much on their native token, for example, because it's probably a scam or something. So there's more than just checking that this thing is done. But yeah, you can check, and maybe the system checks it. I'm not quite sure. Maybe it should. Maybe it can. Good. And again, in some systems you do, in some scenarios you do check. Like in the Polkadot Ethereum bridge, you do check. Or I know that the system checks. Yeah, Snowbridge. I know that it checks. Okay. But what I want to say is just it's part of the transfer protocol and not of the application layer. Yeah. Okay, so having talked about transfers again, which is like the use case, we have these two entry points that I mentioned before, execute and send. Basically, all of XCM can be done with those two. You either want to execute something locally, which might or might not result in a message being sent, or you want to just send the message and do something, like send the message withdraw from my sovereign account and then do something else. But then there are other utilities that the Pallet XCM provides, which are not calls. They're not things that you call from the outside world. Those would be like execute and send. You have stuff like version negotiation. So the XCM Pallet stores with just a Pallet storage, as we've learned in the frame section. It stores the latest supported version for all known chains. So it stores for a particular parachain ID or for a particular location, actually. It stores if the latest version is version 3, version 4, version 5. And that way it can know how to send a message. If you write an V5 message, it knows that if you send it to a V3 location, it has to downcast it or downgrade it into a V3 message. Then we have instructions called subscribe version and unsubscribe version that are used to subscribe to chains to know their versions. So we do use this, we send messages that have this instruction, and then they know they have to send a message notifying us when their version changes so that we can update our map accordingly. And all of this logic of sending subscription messages and updating our maps, that is all done automatically by the Pallet XCM. If the version of a destination is not known, then lowest known XCM version will be used in order to be compatible. So every chain knows what is the lowest version of XCM, and if they don't have an entry on their map that tells them what is the latest version that this chain supports, they will try with the lowest known XCM version. So in the case of Polkadot, it will be version 3. But in the case of another chain, it could be a different version. It depends on what legacy code they're using. That's one thing that you get by default, and it's useful to understand what's going on behind the scene. Then there's the handling responses. So XCM, you just send a message and it did nothing. I mean, you could design a transfer protocol that is kind of like TCP and automatically sends the thing. But because there are assets involved, you need to think about different guarantees that you want. So the simple way to get there, so there's no automatic responses, at least in HRMP and in bridges in general. So one way you can get responses is to include an instruction like report error and tell it to go back. Like in the execution exercise, you saw that there are some scenarios that you can nest XCMs so that you send the message and then you get something back. So you can get data back telling you whether or not it was a success. You can know if your operation was successful or not. And the XCM Pallet allows creating query IDs so that you can send the message, and when it comes back, you can match that it was something that you asked for. And then you accept it. And then this you get with Pallet XCM. Yep. A question?
Yeah, two questions. The first one, if I have multiple nested what's called the instruction like XCMs. Let's say from parachain A to asset hub, and from asset hub to parachain B, and the revert happening in parachain B, it will be kind of aggregate to me in parachain A. Is my first question. Second question,
Yeah,
I
so
need to handle like this kind of like, it's kind of a fallback, not fallback because like I'm handling the response. I need to store it like in the storage, stuff like this, or it will be like automatically stored for me.
Yeah, so there's no revert in the sense that it doesn't go back automatically.
I mean the message. Like, imagine like you have like multiple nested experience, like who will like kind of like notify the other?
Yeah, so if you put like it's an instruction like report error, you tell it where to report the error.
Okay.
So you might even choose to, even if you go via another chain, you might choose to go directly with the error.
Even if we don't have like connected channels between parachain A.
No, if you don't have a channel, then you can't. But you can just send. Do we have a good facility for this? Maybe we do not. But you can send the error back and then probably send an error again. I would need to check. And then the first question was about the revert. That's it. And then the second one was
Handling like in my storage, like
Handling your
I have
storage.
to save it as a storage, or it will be like that.
Yes. So the Pallet XCM. So when there's an error, I don't know what you mean. What do you want to handle in the storage? When there's an error, the assets that are there will be trapped, and they will put in the storage in the Pallet XCM. So you do not need to handle that. And if you want to send a message back, also Pallet XCM will automatically handle creating a query ID and expecting the result. And it will wait until you will get the query ID and you will expect the message to come back. You can at that point, you can, for example, mark something as pending until you receive the response, and then you mark it as complete.
Okay. In a situation where I'm sending asset from parachain A to asset hub, and from asset hub to parachain B, and the revert or the unsuccessful execution happen in parachain B. Now my asset is locked in the asset hub.
No, in B.
I mean, like I already made the deposit to parachain. Sorry, to asset hub. So my token now is, or my assets are owned by the asset hub.
They're trapped in asset hub. Yes, I mean in your scenario, it looks like they will be trapped on B. But yeah, if there's an error on asset hub, they will be trapped on asset hub. So, but they're not owned by asset hub. I mean, yes, they are there. And if there's the governance system in asset hub decides that that those claimed assets could belong to anyone, they could take it away from you. But that's a very, very low possibility. Most of the time, it's like you just send the message to claim your assets. So there's another way you can send a message to claim the assets. Yeah. Okay, and then we have claiming trapped assets. So at the end of execution, if assets are left in this holding register or in the fees register, they are trapped. These assets will live in a storage item under the XCM pallet, and the pallet provides an extrinsic to claim them, but also there's an instruction to claim them. The extrinsic just gives you, just creates the message that has the claim asset instruction. And this asterisk is just that only if the pallet is configured as the asset trapper, you can do custom things because we like generics. So now, continuing our example, we have been working with this example all day yesterday. So Alice would submit an extrinsic of Pallet XCM execute with the call Pallet XCM execute. And that's how everything starts. The rest of the example is the same. Good. So that's the link between XCM and frame and what the XCM pallet does. And then the next thing we will learn is how to configure the pallet. So how to use the how to set the config trait to actually use XCM on our chains. Before that, I want to maybe show some, is it zoomed? Yeah. I want to show some, I want to explore a bit the palette with you guys. So here we go to chain state, for example, and we can search for polka.xcm, which is the usual name people put for their palette. Remember, in frame, you can put any name you want. And here you will see a bunch of storage items. For example, one of them is the safe XCM version, which is the default version if you don't know like which other version the other chain speaks. And here you'll see it's 3. This is Asset Hub, by the way, Polkadot Asset Hub. Then you can, there's some queries with their status, if it's pending or finalized. There's a migration. There are some asset traps to see like the assets that are trapped. And then this is a supported version map. Which will give you, for example, for this parachain, they support version number 4. For this parachain, they support version 5. For this one, they support 4. For this one, they support 4. For this one, they support 3. And so on, right? And that's the part of like version discovery. And yeah, I think those are the most relevant. And there are some constants, I believe. Yeah, like the advertised XCM version. So which one is the latest version that you support? You can just check it here. Like if you're an off-chain application, you're not subscribing, you're not part of this system of subscribing, you can just come here and see the constant of the advertised XCM version or the latest version they support. And then going to extrinsics, you can do execute. This is the execute. It takes a message and the max weight. So the max weight is ref time, proof size, and the message, you can choose the version. And then the UIs will show you like a list of instructions you can use. But of course, this is not the best way of building XCMs. It's quite annoying, actually. So by code, it's much easier with something like Papi or Paraspell. And then you also have send, which instead of it being like a message and a max weight, it's a destination and the message. So you just input a destination, for example, parents 1, and then 1 junction, parachain 2000 and something, for example. And then you want to put a message, and the message will have like a withdraw asset instruction and some more instructions. Right, so those are the 2 entry points, execute and send. Then, what else can I show you? Yeah, we also have some, we also have other extrinsic, yeah, there are a bunch of extrinsics that you can check, like for directly teleporting, some extrinsics that want to help you build XCM programs. But yeah, execute and send are the entry points, and they give you the most flexibility when using XCM. Good. So that's what I had for the XCM palette. Let me see, I want to show you something else first. Yeah, so there's this off-chain library called Paraspell, which lets you just, for example, lets you just do this, and that will create the message itself, right? So you don't need to have like, front-end developers don't need to necessarily deal with all of the instructions and so on just to be able to access, just to be able to use XCM. So this would still, behind the scenes, they would still build an XCM and call execute. But here, this SDK is just like, hey, if I want to send something from, to, and dot this amount, and to this address, and that's it. So I just wanted to mention this.
Cool. So we already mentioned it before. We're going to talk about XCM config. Strictly speaking, we're going to talk about a subset of the XCM config because we already started on it with Pallet XCM. So it's one of the reasons why I pulled up these beautiful things here. This is the XCM config. And here you can see that Polkadot XCM, right? I zoom in, I'll zoom in. You can see that Polkadot XCM, that's the XCM palette that we just talked about in the previous lecture. You can see that it is configured, for example, as the XCM recorder. So the XCM palette does a few things for us. As you can also see that there's quite a bit of configuration here. You can scroll for quite a bit. And we'll cover sort of the key ones that you'll need for the assignment, for the exercise, and that you are also most likely to be using in practice. Let's get rid of this. Right, back to the slides. Beautiful. So what will you learn? Different configuration items available, and the tools available to help configure them. Apologies in advance that it will be slightly dry, but what can you do? This is like it's necessary part of working with it. Right, we have this kind of slight separation between the two worlds, right? We have the XCM world where we have our intention-based virtual machine with these abstract instructions, and then we have the parachain, the runtime world, where we have extrinsics and we have our storage and we have the concrete kind of more implementation detail kind of side of things. And we always, with XCM in sort of parachain land, we always have this kind of mapping between the two that we need to make sure. And that's what, for example, the asset transactor is about. And then we have other things where it's about like configuring the semantics and also the security aspects. So that's the barrier we'll talk about in a second. And then you've already learned about sort of transfers being one of the key use cases, right? And that's where isReserve and his teleporter come in. And we'll talk about the others in a second as well. So the asset transactor. So we have different pallets. These are just some of the ones that you will find already in Polkadot SDK. So there's already different ones in Polkadot SDK, but other teams or you might also have other pallets. And XCM doesn't know where the assets live. So what do? You can even have multiple instances of these different pallets, right? I think we already mentioned that pallet assets, we usually have a local one for assets that are created and listed and managed locally, and then one instance for the foreign assets coming in from other chains. Right? How does the executor is an abstract virtual machine. Like, how does it know where this stuff lives? Well, duh, I already spoiled it. We configure it. So just some available adapters. We have a fungible adapter. So for fungible assets, we can plug in the pallet balances or pallet assets, but it's actually a fungible adapter. So it works based on the trait. So you get even more benefit out of having learned the fungibles trait because it's also what plugs into XCM. So the adapter is generic over any fungibles implementation. As long as the trait is implemented, it will work. And then we have non-fungible, the uniques, pallet NFTs kind of type thing that need to be handled a little bit differently. And same holds true there. So let's go back to our substandard example, right? We have the asset hub, and we want to do a transfer of DOT and USDT to the parachain. And now we know, like, in the background, right, the XCM VM itself doesn't actually know where the dots are and the USDT and so on, and that's where the asset transactors will plug in and actually do the work of moving things around in storage. Like, oh, Alice is now the one that is moving the stuff out, and Bob now owns these things, and of course on the different chains, right? So we move out on the asset hub. So the fungibles adapter will, do the work of moving the funds out of Alice's account, and then we do the whole XCM thing, moving it, sending it over the transport layer, and so on. And then on the para, again, presumably, the fungible adapter will then move the token, deposit them into Bob's account. And what it does, what we do in the configuration is we basically use our tuple pipelining again. And the way it's implemented, it will just try one by one. It'll just be like, first fungible adapter, try, can you handle this asset? And I'm like, no, okay. And then we try the next one. And only if all of our asset transactors fail, that's when we say like, we can't handle it, and then it errors out, and it will trap the assets. Questions about this? No. Cool. You'll see examples. We have, I think I'll go back to the code example I showed you just a moment ago, and also we'll have an exercise so you can try it for yourself. Next one is the barrier. So we already talked about one way of protecting our chain, which is we just don't open a channel. It's like if there's no communication, we can't be duped. But we might need to connect to a chain because there's a particular use case for connecting with it. And then also there is the case where maybe the chain is fine now, but someone crafts some message, and then that's where the barrier comes in. So we want to basically filter incoming messages based on their structure, and for that we have the barrier. And the idea, how I think about it, how we think about it, is it's a firewall, right? If you have incoming messages, you want a firewall. So what's an example for an unwanted message? Well, this one we probably want, depending on how you stand to dot or USDT. But it's probably like, oh, that's a legit token. It's coming from the asset hub. That seems fine. We trust the asset hub to be a reserve for dot and USDT, right? That makes sense. It manages both of those assets. It's perfectly fine. If you have a random parachain that's sending us a random message, we might not want to allow it through. It's not worth it to execute it. So it could be anything, right? There's a lot of instructions. Have you seen the instructions already? Yeah. No? Okay. Right, there's loads. And a program an XCM program in terms of valid instructions, like could be any combination of those, right? But that doesn't mean that it makes sense to execute it. And so that's why we have the barrier as well. What's a good example here? Well, you will see in a moment when we see the available barriers. One is allow top-level paid execution from. That's one of the sort of pre-created, like available barriers that you can just plug in, and that's recommended to use. Of course, you can always write your own, right? It's just code. It's Rust. You can implement the trait, your choice. But this is one of the key ones. And what it just does is it checks, will we get paid for the execution of this XCM? And for a lot of chains, if you have a message incoming and you know you're not going to get paid for it, you're probably going to be very interested in executing the XCM. So you can avoid the whole thing by just doing a little bit of like static analysis on the message and ignore it. And then the other version is like, okay, but there might be chains where you want to allow them to execute without paying for it. A very, very good example for this is you send messages between system chains, right? They trust each other. They trust each other to send sensible messages, and so they want to allow unpaid execution. These are like slightly customizable, but if you want to deeply customize, you will write your own filters. So, right, like, okay, we find no pay fees instruction in the code. Probably not good, and so yeah, implementation detail, but. Right, and if we, for example, we trust the asset hub, and we say, we allow it to execute unpaid. Okay. Oh, sorry. Questions about the barrier? Yeah, we have a question there. Can we get a mic over there? Maybe it's back where I used to sit. By the way, it's really
Is there a
heartwarming to see
way
you
to
collaborate.
limit, like,
Sorry?
can you hear me now? Okay. Is there a way to limit, like, yeah, I accept messages from the asset hub, but I don't accept certain assets, or if the asset hub is like in the middle, so it's kind of like, yeah, the initial caller, or the initial the first parent chain, like call the asset hub, I want to prevent any message from it. So like, let's assume like parent chain A is calling the asset hub, and the asset hub is calling parent chain B, but I don't want to communicate like from the beginning, for whatever reason.
You don't want to receive messages that originate at parachain A,
Yes.
that go via the asset hub to
Yes.
your parachain B.
Is it possible, like, to have like, yeah, this call is coming from this origin, and like, yeah, I don't want it.
I don't remember off the top of my head how much, like, there might be, so the message comes from the asset hub, right? So you can't do it trivially by the origin of the message, because that's the asset hub. There might be traces left in the program of, like, I don't know, for example, there might be a deposit into the sovereign account of parachain A or something. Like I would say, like, it's the same as with any firewall, right? Like, if you make it complicated enough and you're willing to rely on heuristics, you can do some stuff, but also, like, you know, it's possible to obfuscate parts of it. Yeah. Off the top of my head, I would say it sounds like you probably don't want to do that, because it sounds error prone to me. What I would do in your case is, why don't you want to receive the message? And my guess is it will usually involve particular assets. So what I would tend to do is forbid particular assets from arriving on my chain. Because
like, my way of thinking, I might be like kind of like stupid where I'm thinking like this, but let's assume like I have a legit parachain that I can expect, I can trust the code from it, but this parachain allow any other like kind of calls when they do upgrade or whatever, and then it could be used kind of like, you know, like proxy parachain where I'm passing whatever messages, and it could be a source of attack.
So now we're talking not about the asset hub, but about a
Like,
different
I'm just
chain?
giving the asset hub as an example, like whatever, like parachain in the middle, I'm expecting calls from it, and this parachain allow calls from the outside for any parachain or wherever happen, and then I can receive messages from a parachain where I don't want or I don't trust, because like it's kind of like a cycle, you know, like I can, if you don't allow me, like Iman, to come to your parachain, I can like wear another like outfit from another parachain and come to you. So like the same.
Yeah, I understand that you want to kind of use a parachain as a proxy, kind of like to then attack through. It's just that, like, before allowing a channel with a parachain, I assume that you would look at their configuration and at what they do. And if you see that it's exploitable in this particular way, you might not open the channel with them.
Yeah, like if you go via Asset Hub and you have a channel with Asset Hub, then you could still send something via Asset Hub. Like you choosing to create or not a channel what does not allow you to filter things if they go via Asset Hub, for example.
Yeah, but so the assumption is that Asset Hub like processes XCMs in a sensible way.
Yeah.
And is not exploitable in like super unexpected or terrible ways in order to like right there's limits to.
Yeah, I remember yesterday I raised this question if I'm able like to send tokens and arbitrary messages and in one call like in the Asset Hub itself, and the answer was yes. So let's assume like I'm using the Asset Hub and I'm sending a token, but the arbitrary messages, like now I'm from the parachain B, I'm receiving arbitrary messages from the Asset Hub. No arbitrary messages? Like
You mean like you can do initiate transfer, and then initiate transfer has another XCM
yeah, like
program
it
in it.
happened, like I want to call, for example, like I want to log the token and I'm executing kind of like a voting thing, whatever.
So the proxy, because of this, the proxy will never use its origin. So you won't like, first of all, what we saw had a clear origin instruction. So then it has absolutely no privileges at all. So then you cannot be attacked in any way via a proxy, because the proxy, which you trust, the Asset Hub code, like Asset Hub has a sane code, and whenever it relays a message from someone else, it puts a clear origin before the user inject the instructions. So those who user inject the instructions will never do anything. Will never be able to do anything.
Except, of course, what is part of the XCM execution. So you're still responsible for sensibly executing XCM with a cleared origin.
Let's remove Asset Hub from the middle and put another like parachain I do trust, but it's not kind of like a highly trusted parachain by all the system. Like,
then you might want a custom barrier that disallows.
Like my point is like, yeah, I
wrapped
trust
messages.
this parachain because I know like they are doing kind of legitimate things, but the parachain did kind of like upgrades, like a runtime upgrade, and they are allowing kind of like, yeah, we don't have problem. They don't have any problem to receive messages from any parachain for whatever reason, but I have problem to receive messages from any parachain. But now I am, although I set the configuration to accept the messages only from this proxy or this parachain X, I'm receiving messages from arbitrary parachains because the other one.
Yeah, you are right that in this particular scenario that you're describing, you would want to have a custom barrier that disallows like kind of embedded messages. Sure, like.
I mean, you can create it, but like whenever you talk to someone, whenever you depend on someone for some reason, you are vulnerable to attack. Like even in the real world, like if I depend on my friend, I trust on my friend, everything is good. I give him my keys because I trust him, but he doesn't get good best practices and he loses my keys, then I am vulnerable. The same way with a chain, like you open a channel with a chain, your friends, you trust them.
Please use the microphone if you're.
Yeah, no, like if we have a custom barrier or a way, you could implement it. Like we have some adapters and like some barriers built in. They're not that hard to implement. Like it's implementing a trait, implementing a function really that returns true or false if you want or you don't want something to appear. And of course, you can always choose to like cut ties and cut your barrier, cut your channel. Yeah.
Yeah, I expected a little bit of discussion like this on the barrier because I think it's important and security relevant. And thank you for diving in a little bit. Anyone else? Any concerns or questions about the barrier, about this kind of stuff? Please talk with a microphone.
Do we have a built-in a filter for assets Like, okay, I'm accepting the calls from asthub, but I don't want to support this kind of assets.
This is something that we'll come to in a moment with the reserves and teleports. Actually, it's a good question. If I, no, it's probably better. Yeah, we'll talk about it in a second. Okay, I'll keep going. Location converter. So right in XCM land, we have these locations. There are these kind of path-like constructs that we've gone into a lot. I think, thank you for the detailed intro, because I think a lot of people get confused about them, and it's one of the key parts. So this is how we get the sovereign accounts that we already talked about. And it means that, just to make it very, very clear, it means basically anything that you can represent in XCM locations can have an account. That's sort of the implication. That's the beauty of the flexibility of the thing. Yeah, sorry. Okay, we're just going to talk about a second first. So you can have a pallet on another chain be represented as a location, and then, right, if you have the right location to account ID converter thing, that means that other pallet on that other chain can be represented as a dedicated account on your chain. And of course, right, you need to make sure that the converter is doesn't have collisions, right? So the first one, super easy, account ID 32 alias. Super straightforward. There is an account ID 32 kind of enum variant in the location, as like a junction, I think it exists in there, and you can just extract that and use it as an account ID. Super straightforward. Super generic, very nice. You can just hash the description, sorry, you can just hash the location, and as long as the location is unique, you will get a unique account ID out of it. Another one that's not mentioned here is the one that we use to create a dedicated account for a parachain. Actually, let's see if we can see that one here. Sibling. It's not the one. We're going through all the different, okay, let's see if I can. Okay, okay, Shem, we use, we don't have it here, sorry.
Sorry, Alex, can I just ask, what repo are you looking in there?
Sure. Yeah, I'm in the Polkadot Fellow. Yeah, you can see it because the Zoom doesn't show it, right? I'm in the Polkadot Fellows runtime repo. So, right, we have the Polkadot SDK, which is incredibly useful if you want to just look for all the different, kind of features and things that you can use in Polkadot SDK. And then the Polkadot, maybe someone can put the link in the Discord. The Polkadot Fellows runtimes repo is where the actual Polkadot runtime and the actual Asset Hub runtime and the actual and so on. The actual runtimes are being managed, being programmed, and so on. Reason being that we want the Polkadot governance to be in full control of its runtimes, right? While Polkadot SDK it's a framework, it's an SDK for developing chains. Lots of people use it, and the idea was to make that distinction a little bit clearer, and so that's why it's a separate repo.
So for us, not just for our assignment, but maybe just that's next in line. When would we look in this Fellows runtimes SDK for understanding structs or whatever that we're using, and when would we look in the Polkadot SDK?
So you would look in Polkadot SDK for how is, for example, with latest location converter might very well be from there. Definitely the one I showed here in these ones, the available converters that we recommend you use. These will be in Polkadot SDK as reusable components. And then the runtimes are a great example for one way of configuring it, right? Because there's a lot of configuration. That's why we have this, we have a whole talk about the configuration. And if you want examples for how to configure parachains, then they are candidates. Do keep in mind, though, that they are system chains. I think there is no non-system chain in the Polkadot Fellows runtime, right? It's all system chains, well, and the relay. So you want to make sure you understand, like, note that the configuration you see is for a system chain, which will be different from what you will want in yours. So you're also encouraged to look at, what does hydration do? What does Akala do? What does Moonbeam do? What, what do the chains in the ecosystem do? What kind of configuration do they have? Also recommended, also good. You want to add something, Cisco?
Yeah, so there are no non-system chains on the runtimes, but there are on the Polkadot SDK. You can go to like the Western chains, and there's one called the PenPal, which is a non-system chain that has some sensible configuration. And also the templates should have already a sensible configuration. If you go to the parachain template, it should already have a good XCM configuration. So you can, hopefully after this, you can look at it, understand it, maybe tweak it, but there should be like a default in the template. So if you do, for example, pop new parachain and you start the parachain, downloads the template, you should already have a good configuration to like be able to do XCM.
Yeah, so you're not overly exposed and stuff. Yeah. But still recommend it before you put anything right into production. Do an audit of the XCM configuration. It is an attack surface. So we already said that we would talk about this. Is reserve and is teleporter is like one of the key concerns is like what kinds of assets do we allow into our chain? And the is reserve and is teleporter are another kind of layer of firewall that's specific to assets. So here we have again a transfer, and this is a reserve deposit, right? So inside of the XCM we find the reserve deposit instruction, and when this arrives and is executed, so this is a little bit later. The barrier is the first layer of defense. The is reserve, as far as I remember, is executed at execution time of a reserve deposit. It will allow you to configure which kinds of reserve deposits to accept. You have a question?
Yeah, if you can go back 2 slides.
Two slides.
Yeah, the converter.
1, 2.
Yeah, like here, like these are kind of available, like for me, up to me as a runtime developer to choose any one of them. And I guess like the output will be different. Like the sovereign account key, like the key itself will be different, correct?
The key would be different for these two, yes?
Yeah, so like I'm just confused because I feel like there might be kind of like things I need to consider while I'm selecting this. And let's assume like I made kind of upgrade. I have to keep the old converter I'm always using.
Yeah. Yeah, my recommendation is, again, this is again a tuple kind of situation where we go through the tuples. Sorry, the elements of the tuple. So my recommendation is have the most specific location converter first, and then have the lower ones be fallback, similar to like a match statement in Rust, right? Where you might, here's a very specific condition, then we do X, and then you have a fallback one below. That's how, like, and then there's also convention ordering that you will see in the repos. That's what I would start with. But if you want to add something, then you probably want to add something specific. And then I would recommend you put it first, because that way, yeah, like the generic ones are kind of the fallback.
Yeah, and also like before we used to have a lot of converters that we expected people to use. Now we just have those two, which are, if you just use those two, then you are done and you don't need to do much else. You could in the future add more to hash description, because hash description, like you choose which junctions can create sovereign accounts. So for example, you could use hash description and say only parachains can have sovereign accounts. And in the future say, okay, also accounts on parachains could have their own sovereign accounts. You choose that, but yeah, once you make a decision, you should keep it forever, which is the case with many things in blockchain in general. And then the first one, account ID 32 aliases, just means if I receive a location which is an account ID 32 junction, just map it to the local account ID 32. So that one is just very simple. And the other one, yeah, will hash and concatenate all the junctions and give you an account. And you can choose to have sovereign accounts for pallets, for example, or not. So you could start with a very small thing and then keep on adding things as you need, versus the other way around, which would break everything if you remove something.
Oh, sorry. Okay. So for a particular asset, we will ask the question: is this an allowed reserve? Like, is this an allowed reserve deposit? This is so the reserve deposit will come before the clear origin, so we can check. Oh, for this particular origin, do we accept that as a reserve for the reserve deposit? Or if it's a teleport, right? Teleport instruction, like same thing in green, right? Do we accept this origin as a teleporter of this particular token? So here the example is between the asset hub and the people, like another system chain. And then, like, yeah, of course, we allow teleporting dot between system chains, right? And here we have asset hub and a random parachain, like a non-system chain. And like, do we accept dot as the reserve? Do we accept the asset hub as the reserve for dot? Yes, we do. So what is the convention? The convention is you accept chains to be their own reserve, right? If you get the native token from a chain, you accept it as a reserve. You will, as a non-system parachain, you will probably not accept teleports very much. I can't think of an example where you would want to. Do you have one, Cisco?
Yeah, so if you register your asset on Asset Hub, you would accept teleports.
Yes, right.
For that, but that's
Okay.
the only
That's
case.
the
The rest
only
would
example.
be reserve
Yeah.
transfers. Yeah.
Okay, cool. Yeah, so that one exception notwithstanding, as a sort of generic chain, you trust no one. And then, of course, right, you might have like a bridge, and then the bridge will be the reserve for the bridge tokens and so on, right? There's some flexibility here. Questions about the idea of, yeah, do we have a question over there? Can we get a mic there?
At what point in the transaction lifecycle is this blocking actually happening? Like, is it possible to DDoS this?
Is it possible to DDoS this? So this is possible to DDoS by another chain where you accepted a channel and where the barrier does not filter out the message. So yeah, if you have a channel open with a chain and your barrier does not prevent you from being sort of DOS in a particular way, yes, that chain can send XCMs to you that, for example, that fail this is reserve thing. And so yeah, they could potentially fill up your sort of the budget you have for XCM execution, the weight budget for that. They could fill it up with their bullshit instructions. Bullshit
Okay, but
messages.
you have to like manually accept every channel.
You manually open every channel, yes.
Okay.
Except maybe to the relay, I don't remember, but yeah. Yeah. Yes. Yeah, so that is like you will want, again, right, it is an attack surface, you will want monitoring around your chain. And if you notice that, a particular channel, has a lot of transaction, like a lot of XCMs coming through that are not really doing anything, like you're wasting cycles, right? And I think there might be some like randomness, round robin, or randomness involved in like which XCMs to execute from which chains. So I think it's not a huge concern that you will actually get totally congested by one other chain sending bullshit XCMs. But it does like burn execution time. Cisco has
Yeah, so you do some round robin with all the channels you have open. So you have like 10 channels open to different chains. You will process them like one from each.
Yeah.
So if one is malicious, you will still attend the others. And when you realize, like, so you're not overwhelmed, and when you realize that they're overwhelming you, you might like cut the channel maybe, or to cut a channel does not require an upgrade. It's an extrinsic, and you can cut it.
Maybe just as something I'm wondering, like, isn't the ability to cut a channel at any time also a problem? Like maybe if you have a marketplace on, like maybe not Asset Hub, but maybe something like Asset Hub where people can make trades, and maybe you're realizing that the value of some asset has gone down too much and you don't want to accept messages anymore to withdraw it.
I mean, it's not that you can cut it at any time. You would put it under root, and then it would be a governance thing to cut it. Like, yeah, of course, you can have a chain which doesn't have governance and doesn't have upgradability and just never changes. And it gives you some guarantees for sure. But if you want to be future-proof, you use substrate, you have governance, and you can like adapt to future scenarios. I mean, but you're not expected to change it every day. It's the same thing with a country. You're dealing with a country or with a company. You don't expect them to change their laws every day. So yeah, but at some point there might be a good reason to change it, and then it would need to be very well communicated and documented and agreed upon and so on and so forth. And that's because there's not just one guy that can do it all the time on a whim. That's the idea.
I have another question there. Maybe you can pass over the microphone.
So in some of the XCM messages in the set of instructions, first instruction is unpaid execution. What exactly does it represent? And then later I see we are also paying the fees anyway. So what does unpaid execution, like why is it needed?
Where?
In some of the XCM examples, I'm seeing in the set of instructions, the top instruction is unpaid execution. And then there is also a fee payment execution, fee payment instruction.
In the XCM like workshop or in the where?
This is XCM documentation and the examples,
Documentation.
unpaid
Okay.
execution.
Yeah, so there's no fee payment there. Yeah, there's no fee payment. So.
In some of them there is.
Yeah, but not there. You can either choose to do unpaid or not paid. I will answer with.
Yeah.
Like, are we talking the instructions here?
Yeah, so unpaid execution is an instruction that you can use just to signify that you will not pay for fees. And it's meant to be for when you want some other chain or some message to not pay for fees for some reason. So maybe because they are your business partner and you don't need them to pay for fees. It's because the chain is the root. Like you maybe don't expect the relay chain to pay fees or whatever.
And you can choose to either put unpaid execution or to use pay fees. We have barriers which check. If it's unpaid execution, they will check like where is it from, if it's possible that they do not pay for execution. And if it's pay fees, they will check if they need to put pay fees. When you use the initiate transfer instruction, there is a remote fees field. And if you don't put anything on it, if you put a none, the remote message will automatically have an unpaid execution instruction. That's why the remote fees, as you see it, it's an option. If it's not an option, then it will include the pay fees instruction so that everything works correctly. Most of the time, you would want to pay for fees because else it would get rejected. The non-paying for fees is mostly for the system to be able to say, hey, for example, between two system parachains, between two system chains, I don't want to pay, I don't need them to pay for fees. And that's it. For example, when the treasury sends a message from the relay to Asset Hub just because the assets are on the Asset Hub, we don't want that message to need to pay for fees because it makes no sense to like have the system pay itself. Yeah.
Yeah, here in the front.
Is it possible?
No, we have a question here in the front.
So it's a high level question, conceptual. Apologies if it's borderline stupid, but if anyone can set up a non-system chain with its own assets, register those assets on Asset Hub, just because it's in Asset Hub, why, if anyone can do that, why does that suddenly make it more trustworthy by the barrier to say, is it in Asset Hub? Yeah, cool, maybe I'll trust it.
As in the Asset Hub acting as a reserve
Yeah,
for the...
if anyone can do that.
Yeah.
Just because it's there, if there's no guardrails for who can register what in Asset Hub, why does that suddenly become more trustworthy to the barrier?
So I would say that it actually does not become more trustworthy because the default configuration is that we would trust a chain to be the reserve for its own native token. So trusting the Asset Hub to be a reserve for the native token of the particular chains is not a huge difference to the chain itself being, right? Like, so I would say it's consistent. Maybe I'm forgetting a particular scenario that you're thinking of.
One of your, I didn't fully write down your sentence, but you gave some scenarios and you said, as a non-system chain, I would not typically trust assets coming from there, and Cisco gave a different scenario where you would if it had its tokens registered in Asset Hub, and I'm like,
okay, so maybe it was a thing with the teleport.
Yeah, that was it.
Yeah, so you do not, let's say anyone can build a chain, right? It's permissionless. I build a chain, Cisco chain, and I have my own token and so on. You build your own chain and you want to send tokens to me. Great, just do a reserve transfer. You put some of your tokens on my sovereign account, I mean on the sovereign account of my chain on your chain, and then just send a message to me saying, hey, you got some balance, means some derivatives. I do the same to you. I am the reserve of my own token. You are the reserve of your own token. And our users, if we manage to get any, will be able to use our token, like each of our tokens on the other one's chain. And that's perfectly fine. We wouldn't use teleports because that's not how you would use it. Now, let's say I don't do a channel with you. I just have my channel on Asset Hub. I would accept the same thing from Asset Hub, reserve transfers, not teleports, just reserve transfers. But then you can register on Asset Hub your token, and then you do teleports with Asset Hub so that both your chain and Asset Hub are reserves, like both count as reserves for your token, so that I can do reserve deposits, or sorry, reserve withdrawals with them. And I could also register my token on Asset Hub and teleport to Asset Hub, but then we just deal with reserve deposits anyway. So it's the same thing, like it's consistent, as Alex said, like I'm not allowing teleports from anyone other than from system chains.
well, sorry, I'm not allowing tables from anyone really. And then if I just like, there's this feature on Asset Hub that you can kind of share ownership of your asset, so that Asset Hub also becomes a reserve, and people can also use it as a reserve. Because by default, only the like origin of the token is a reserve, but you can also share that with Asset Hub as well. But that doesn't involve any other chain than your chain and Asset Hub.
And so the extra trust that we're putting in here is that we will very likely open a channel with the Asset Hub because we want to exchange messages with it. And what this allows is you can have that trust with the Asset Hub for it to send sensible XCMs mostly, and for, you know, have token and blah, whatever, and so on. And you could then accept more tokens than you have channels with other chains with, right? Because otherwise, for every new token you would want to accept, you would need to open a new channel to that particular chain. And I mean, I'm just guessing. I was not involved in the decision on making that, but like that would be why I would do it. Yeah.
I have a question related to the fee calculation, not the fee calculation, like the idea of like having fees an option where we can have no fees at all, like the follow-up question regarding the remote fees and
This
stuff
one,
like
the initiate transfer?
Yeah, like my question is like, can we have kind of like partially free, like let's assume we have like two like connected chains to go to my destination chain, and one of them or my destination is free, but in the middle is not free, stuff like this.
So at every point where you do this initiate transfer kind of thing, and any place, if you look at the instructions, and whenever you have this remote XCM or this like embedded kind of XCM message, you start a new program. Usually it also means that you will be in a different location. I'm not sure that that's guaranteed, maybe sometimes not, but like usually you will be in a different location, and you definitely will be in a new XCM execution context. And then you, again, it's a program, it's an XCM program, you again get to include whichever instructions, which might be paid or unpaid.
Can I utilize the benefit of other like connected parachain that has this privilege, like free transaction or free execution for their instruction, and then I can pass whatever things there for free? Because like now the origin is like this parachain.
I can imagine a thing where you send a message to the Asset Hub, then the Asset Hub would send a message to another system chain, and then and it's configured in a way that the Asset Hub gets free execution on the other system chain. Like that's possible. I don't know whether that is configured that way right now.
Okay, my last question, like regarding fees, like if I miscalculate the amount of required fees, it will be reverted in the this chain, correct?
If I misconfigure the fees,
like let's assume like the required fee is $1, and I put 1.5. Sorry, 0.5. It will be reverted. There is no way before executing it, like to kind of.
It's not that it will be reverted, it's that it will be halted, and then whichever assets are left will be trapped.
Yes. Thank you.
Yeah. Let's go back to the slides. Wait, we're back on the call. Why are we back on the call? Okay. He'll be fine. Wayer. So we've talked a bunch about we want to pay fees, right? Unpaid execution, paid execution, and so on and so forth. If we want to pay fees, we basically have two options as usual. We can do gas metering, or we can do benchmarking. And as in the rest of the like parachain Polkadot ecosystem where we do weighing, that's also the default that we use here. I'm asking myself the question right now, like, oh, would it be possible to do gas metering? Actually, that would be an interesting exploration. Like, could you build an XCVM that is based on gas metering? I don't know. But yeah, so for us, it's weighing. We'll You want to respond to the?
No, I just
Shelter?
wanted to a very short thing. Yeah, you might be able to do that with PVM and RISC-V, maybe not with WASM, but yeah. You can.
Yeah, probably not, right? Yeah. Yeah, you will. So with the parachain, you will need some weighing somewhere, because that's what the system is based on, and then maybe you could do metering of the XCM based on nonlinear. And that's sort of what we're doing, right? It's like we're looking at the program, and then we're like, it includes these instructions, and then we map them. I wonder whether you could call it. No, it's weighing. So we assign a weight to each instruction. How do we do that? We benchmark the instructions. Yeah, so there is, you have the benchmarking. Oh, we benchmark every pallet, and now the other thing that we need to do is we need to benchmark all the different instructions that we have, so that we can determine their weight. And then in terms of the configuration, like this is not a whole lecture here now about benchmarking of XCMs. That's out of scope. But what we want to look at is how do, okay, we assume that's happened, and now we want the executor to be able to weigh the instructions and to determine the weight, to then charge fees. And basically, there's two general options. One is we just use fixed weight bounds if you haven't done the benchmarking, and you use that in testing, or you have the weight info bounds where you have done the benchmarking, and that's what you would use in production. So we need to do the benchmarks, and the configuration. So that we've covered some of the configuration, right? The is reserve, the various sort of, like all these kinds of things change the benchmarks. Yeah, so we need to benchmark basically, again, we have this case where we need to take the whole runtime as it is, as we want to release it. And that's going to be our basis for benchmarking, because everything in there, like one example that's given here in the slides is, right, different asset palettes have different implementations for how the accounts are handled. And so we need to benchmark to see how expensive is it for our particular case. And you could have UTXO in there, maybe. You could have all kinds of things. And we have the usual, always benchmark the worst case. Actually, a thing that's not mentioned here that I'm reminded of right now, maybe you've already seen the all counted enum variance in the asset filter, right? Yeah, you've covered that. And one reason why we have the all counted is actually because the worst case is quite bad. It could be, like an asset filter could be quite big. The worst case is a lot of assets being selected for a transfer, for example. And so the all counted is a way of constraining the worst case, being like, well, it could be any asset, but it's only going to be one. So we know how to weigh it, and so we can charge more accurately. Because the worst case, average case are quite different as usual. Any questions about the weighing, the weight configuration thing?
Nice, it works. Good. So hope you have a nice break. We want so I checked a bit in which stage you were with the assignment with some students. I want to make sure that that you can do the assignment and everything is fine. So maybe a show of hands who has started the assignment. Raise your hand. Okay, a lot of people. That's good. Then let's do another show of hands. Who is stuck implementing the first part? Raise your hands. Okay, so some people are not actually stuck. That's good. And then, okay, and who is stuck testing the first part? You cannot be stuck in both. You need to. I mean, if you do, yeah, test-driven development. Okay, I don't. Okay, so some people are already testing their stuff. Okay, and then I guess the second part is anyone implementing the second part? Show of hands. Okay, good. Yeah, for the first, you do the first one. Okay, so testing. So we will talk about the emulator, which is the testing framework. We have you have seen it on the exercise. So there's a lot of things that you can take from the exercise that we did yesterday, so from the workshop, and apply it to the assignment. But here we'll give you just a more official introduction to the testing framework. So yeah, the XCM emulator is just a Rust crate that you can use to test your cross-chain interactions. It's a collection of macros that create a mock network that we can use to test our XCM configuration. So we are emulating that we have a network, that we have multiple networks, multiple chains, and we're sending messages between them. But we are mocking all of that, so you don't need to do like ZombieNet and actually execute different chains and send messages between them. ZombieNet is perfectly reasonable to use to test XCM, to test cross-chain scenarios. There's also Chopsticks, which is very useful because it also starts like different chains, and you can then write your tests on top of that, on top of those chains. But the XCM emulator is a Rust tool that will allow all of this to run in a single thread and will mock all the different runtimes. We've seen this before. We've seen this yesterday with the execute with function that allows you to just say, okay, I'm going to execute this bit of code on one parachain, done. Then I'm going to execute this bit of code on another parachain, done, and you keep on going. And it's all just one thread. You can very easily debug it by just turning on the logs. Yeah, so let's look at how this works. So creating a mock network, we need to create our runtimes. So we need to create our emulated runtimes. Sorry about that. So if you go into your assignment, there will be, there is an emulated tests folder, right? I expect all the tests to be written there. There's in emulated tests, there must be, I think, a module called network, a module called chains, or just a module called the asset hub west end, a module called the west end, a module called parachain, something like that. And then for those things, if you go in there, you'll see like a decal test, relay chains, where you create a struct called relay. This is very similar to the construct runtime syntax, but you need to specify a runtime. So just specify the relay runtime. This is the crate of the runtime. We import the west end and asset hub west end runtimes, and we use them there here. Then it has some core thing, some pallets, some Genesis, and some on-init code, right? In your assignment, I guess the only thing you care about is this core and pallets. Everything else you shouldn't need to worry about. In pallets, you put the pallets you can use when you do as para pallet, and then angled brackets, and then colon, colon, and the name of the pallet. Like here, you would have your balances, your assets, your foreign assets, your polka.xcm. Then in core, you have some specific things like sovereign account off, which is the location converter. This is a function you can use to get the sovereign account of a particular location. There's also an example of this in the execution workshop under the setup function. So we probably will look at the setup function. I think that will be relevant. There's also an example at the end of these slides. Then we have this, how do we declare parachains? And we have this decal test parachains. But it's the same idea, right? You have the runtime, you have the core, which in this case is a bunch more things like parachain info, which is core because it will let you get the para ID. Then the message origin, the message handler, those you don't need to worry about too much. And then in the pallets, you see we have like a system pallet, which is literally the same alias system that you see on frame. You have the balances palette, the foreign assets palette, the Polka.xcm palette, for example. So the result of these two macros give you like these structs that you can use to get all the information you need. Then there's another macro called decal test networks, which will create a new struct called the mock network or whatever network you want. You select the relay and a vector parachains. And then optionally a bridge, because we also use this to test, for example, the Polkadot-Kusama bridge. Any questions until this point? Good. I went very quick, but it's just declaring stuff. It's not what you need to do. Now, how do we use this mocked network? Oh, yeah, sorry, there was a question.
Where is the ID of the parachains defined?
Where's the ID of the parachain defined? It's in this parachain ID. No. Yeah, this parachain info. I'm not selecting it. Am I here? Yeah. Oh. It is in this parachain info.
Parachain info.
So where it's defined is in the relay chain. Like in the real world, you get assigned your parachain ID when you register a parachain ID on the relay. So you can go in and say like, hey, I want a parachain ID, and you get like a 5,000, and it keeps on increasing and so on. But then you store it in this parachain info thing. And this decal test parachains, in this struct, you can do : para ID, and you have a function that returns the para ID. So that's all good. We will show an example of that now. So then you only need to specify parachain A and parachain B. And they already know their own para IDs because of that parachain info that you use. So how do you use this? So if you look inside of the emulator, you will see this code, which is ugly because it's a macro code, right? So here I'm relying on you being able to ignore the characters that you don't understand and try to get the idea. So the emulator creates a trait, right? We can all agree it's creating a trait. And it creates an implementation of that trait for our name. Okay? So we are creating a trait. The trait is called name para pallet. So this name is the name you use here, like the para A would be the name. And what we do is we create a trait called the name pasted with the actual string called para pallet. In your cases, we don't do para pallet, we just do pallet. And that trait just has associated types for each of the pallets. So that's why if you saw on the example, and we will see an example again, if you just grab, you will see the runtimes that you have available, the chains you have available are West End, Asset Hub West End, and Custom Para. Now, at any point in time, you can say Custom Para as Custom Para Pallet, so the name and then pallet, and then : and then you have access to all of the pallets because they are just associated types. And then, yeah, no, just this that trait is implemented for all of the, yeah. That's the thing. So the only thing is you can access all of the pallets in your runtime. We'll see an example now. Another trait that the emulator defines is chain. Let me first look at an example. So what I mean is that at any point in time, if you want to access a pallet, you just do this, okay? So all the previous code was a macro code. It's ugly to understand, but here, let's say we wanted the balances pallet of our para A. We just do para A as para A pallet. So this would be the trait. And then we access the associated type balances. And now we have access to balances. So for example, we can do balances as fungible mutate, mint into when we mint something. right? We have access to the pallets that we have defined on our thing. Another trait that the emulator defines is this trait called chain. Chain, you can always do para A as chain, and then colon, colon, and try to use the things from inside. Chain will give you access to, for example, the events. So you can do chain para A as chain events, and you can print them, and you can see all the events printed. You can use account ID of, and you just put it a seed that is a string, so just any string, and it will give you, oh, no, okay, it has to be a hex string, I think. It gives you an account ID. This one, it's not that relevant. But then you can access runtime call, runtime origin, runtime event. Like if you need an origin, you can just access it here, and you access the runtime origin. I'm saying this because in calls, the first parameter is always the origin, right? Yeah, and you have more, you can access all as well all the things in core, like sovereign account off, for example. So let's look at an example, which is what will tie everything together. So we just create an example. We can reset the network so that this mock net was created with the network macro. We can do a reset. We can do execute with, saying, hey, we are on para A. That's how we manage with this execute with. We manage executing in different contexts. We have some state initialization, so we have some sender, we have some initial balance. We get the balances palette and we mint into the balance, into the initial, like into the sender. Here I should have completed this, but the sender, you can use para A sender colon colon get. Like I provide you with this, or the emulator provides you, if you see in the assignment provides you with this custom para sender, asset hub Western sender, right? You can get an account easily if you use that. Or asset hub Western receiver, custom para receiver as well. Then you can actually do the message. So you create an XCM, some XCM, and then you can do as well like para A as para A pallet, XCM pallet execute, or this could be Polkadot.xcm as well. The name on the relay chain changes for reasons. And then execute, and then here is an example of how you can access the runtime origin. It's para A as chain, runtime origin, sign, then you get some signed origin. Here you could use para A sender colon colon get. And then, yeah, you do a message and you do some wait. So we had the setup, we had the message. Now we can do some assertions, right? So we do balances as fungible inspect. We inspect the balance and we insert the final balance is equal to the expected balance. Then we can go to para B, print the events, just to debug, to see what's going on. And then we can even assert on events. So we can assert, for example, that the message was successfully executed. So on para A, we sent a message. The moment we call execute with on para B, the message was already sent and was already executed. So we can assert that that the message was executed. You can assert other events like balances minted, balances burned, balances issued. And then we can do some final assertions on the balance, for example, which here I didn't put an assert equal. But yeah, here is how you would get, for example, the foreign balances, the foreign assets. And then you just do as fungibles inspect, and you get the balance. And there should be an assert equal probably at the end. And yeah, any questions? No? One question at the back. Mike. There.
I'm just confused about, like, this is how we can like test, but for
Yes.
the emulator, what we already have, is there any configuration we have to add or?
This is just how to write a test with the emulator. So in the assignment, you have an emulator folder.
The setup is ready, because I was confused.
Setup is ready. Yeah. So setup is ready. So the decal test, like all of these things, let me see. Yeah. So all of this decal test, relay chain, parachain, like all the setup is done. You have it. You can take a look. It's there. And then the only thing you need to do is create the tests just like this one. You can literally grab this test example from the slides, which will call things from A to B and paste it there. You can also go to the execution workshop and you will see examples of how to test, right? Because the whole execution workshop is in an emulator test. Then another thing I can show you. Any other questions? Yeah, one over there. Yeah, passage. Yeah, okay.
But the test environment is quite different because in the workshop we're not using like a custom palette or no.
You're using a what?
A palette.
A palette. Oh, okay. So in the workshop, yeah. So in the workshop you are. So for example, here we are doing XCM Pallet execute. In your assignment, you should do XCM utils and then the name of the call that you implemented, right? So this is how to call a pallet. And the setup is already done. Like this, your pallet. So in the assignment, you have an XCM utils pallet. And it's already set up so that you can use it in this way. You can do custom para. I think it's called custom para. So custom para as para, custom para palette, XCM utils, and then the name of your call. And that's how you can test it. Yeah, over there. Nice, thanks.
Can we see an example of how to get the sovereign account ID for sibling parachain?
Sure. Sure. I wanted to, yeah, after that, yeah, I wanna maybe get to the configuration, but I want you guys to be able to pass part 1 first. So yeah, I'll give an example of that. Is there any other question regarding testing though? I will give an example of that, but I wanna make sure you feel like you can test, right? You have this example, you have the execution workshop example. I could also, in the afternoon, we will do all assignment work. Live coding, I will, in there, maybe I can do an example. But I'll give you a little tip before. But yeah, if everyone knows how to do tests, then that's great. I wanted to show some real examples, so I believe I can, nice. I believe I can show you this. So in the Polkadot SDK for a repo, in Cumulus parachains integration tests emulated, and then tests. And yeah, we have tests for like Asset Hub, Bridge Hub, collectives, like for a bunch of chains. You can see a bunch of tests. If you go, for example, to reserve transfer, I mean, here you're testing pallets. So for example, you will see this assert expected events. I think the actual tests are way below. So let me just search for the test. Oh. Nope. Okay. Test. Let's see. Search for tests. Come on, man. Okay, so we have a test. So for example, you will see we use exactly the same ideas, right? We do westend as chain, runtime origin, signed, and then westend sender get. Right? We use this same code you can use on your assignment. And then the destination, this is also something I believe you can do. If not, maybe we change it. But it's a child location off, and you can give the location. We also have here ascent have western receiver that you can use. This is just XCM stuff. And then we have an execute with that you can use. I mean, yeah, you will use the execute with. And here, as you see, we are executing some pallet call in your assignment. It will be the XCM utils and one of the two calls that you're actually using. Then this is the same thing. I mean, we use that all the time. Okay, and this does some weird things that we maybe do not want. Yeah, never mind. I think that's it. So that's how you can get like real examples. What else? So this is done. And then, yeah, there's another possibility to do something, which is chopsticks. But so that is it for this. You wanted some example. Maybe we should do it, but this is not my machine. Alex, are you okay with me showing some code before the workshop?
Am I okay with, or are you asking for a suggestion?
Yeah, if you're okay with it.
Sure, yeah.
Yeah. I need to share the right screen. Okay, yeah, makes sense. I need to change what I'm sharing. Okay, so this is the XCM workshop, so it's not your assignment. We could use your assignment. I don't know if it's downloaded on this machine. But
It's somewhere.
What?
It's somewhere.
It's not?
I think it's somewhere, but let's
It is
do the
somewhere.
workshop.
Okay, so we
Let's
can try to find it. But you will see something very similar, right? You will see an emulator which has all of the things already set up for you, right? The things we've been talking about. They're all set up. So you have Asset Hub West End, you have a network, and you have the relay chain West End, and you have your custom parachain, which here is just called custom. Yeah, it's going to be called custom para. But then, yeah, let's go through the execution again. So it's in the wrong branch. Okay, I'll just change the branch. I think it should be execution. There we go. Okay, so now let's go look at the exercise because we didn't finish the exercise, right? So if you go into the execution exercise, you will see it has these tests, and it has the same things that you have on your assignment. It has the West End, Asset Hub West End, and custom para types. They all come with accounts called sender and receiver. For example, Asset Hub West End sender. And you can use : get to get it. And we've seen the cross-chain transfer. Hopefully that's good enough by now. You see how, XCM takes in this runtime call type. right? This runtime call type, sometimes let's talk a little bit about this runtime call type. So this runtime call type is because XCM is generic over a runtime call, because there's an instruction called transact, which uses a runtime call. So XCM is generic over a runtime call. So if you want to send the message and execute some code on the other chain, you usually just put unit, because you don't know the type. So here we see it again, but we will actually find an example where we don't care about it here. So in this example, transfer and transact, which is one example you should really take a look at to see how transact works. You will see that we are getting a remark, constructing the call by using this asset hub western as chain runtime call, and then literally the same thing you were doing before on frame. And then what you do is you do transact and you pass in the call. And the XCM just can use unit as the runtime call, because you don't know the runtime call of the chain that you're sending to. It could also be just this type. It could actually be this type. Because, yeah, you know the type actually, it's this one. But any one of those is fine. Let me just go back. Okay, I just wanted to mention that a bit. And this runtime call in your assignment, you have 2 enums like in your palette. Do I need to be close? No?
No.
Okay,
Yeah.
good. And now it is, yeah. Okay, so you have 2 enums that mimic the runtime call on the other side that you should use to encode it. Now regarding the sovereign account, yeah, I would like to find the actual. Yeah, here it is. What is this? Oh,
This is my work on the assignment.
yeah, I'm stashing it.
Spoiler.
Okay, I believe it has been taken.
What are you looking for?
No, I just want to go for the palette. Each you have stuff. I thought
this is the implementation, yeah.
Yeah, I thought I stashed it. Sorry,
So you
I
didn't.
grabbed the thing and I put stash, and I'm going status. Okay, I'm going to do code again, then code dot, maybe that works. It doesn't. Okay, it doesn't. Okay, never mind. I don't know how, sorry. I stashed it and it's still here
Because I committed it.
I committed it.
You need to check out another branch.
Yeah, makes sense. Okay. Nice, thanks. Okay, that should be good enough. There we go. Okay, so we're here on the assignment. I just want to show you the assignment. So you have two calls, right? You need to do ensure register native asset on Asset Hub, and then the other one, which is transfer to Asset Hub. I showed this yesterday. I just wanted to maybe show you, give you a few more tips. So this enum mimics the runtime call enum of Asset Hub. It has the right index and the right inner call and the right index and the right signature, so that you can create this type, encode it, and get the correct encoding that you need without needing to import the crate, like the other runtime. Another tip is for using XCM. So you're gonna want to build an XCM, right? Like, of course, you will want to do something like, whoa, something like that maybe. Probably not, but yeah, you're gonna want to do some, I don't know what was so funny, but
You
you're
can switch it
gonna-
off with Command Shift P and then snooze.
Yeah, I mean, it's fair, right? I mean, that's not what you have to do, so. Command Shift P, you said, and then snooze inline suggestions, yeah. Let's just give it for a while. Okay, so you do builder, and then you wanna, you don't have to do builder, you can just do it in another way, but you're gonna want to put your XCM, right? Like with all the things that we talked about, so pay fees, and all of these examples are on the execution workshop. And then you just, you will need an XCM, and then you have this type on, this associated type on your config trait, which is XCM, which implements an execute controller and send controller, which all it means is you have access to the two entry points that you want. You can either do T, : XCM : execute, or you can use T : XCM : send, right? And you're gonna have to use both of these. One on one colon, another one on another colon, okay? So just for those of you who are confused of how to actually call XCM, you have this configuration traits that you can use, and it will work. It's already set up, it's already configured, you just use it. And then for tests, you would just go into tests mod and create some tests. So for example, here you have some examples of how, yeah, you do execute with. So probably you would do, you change the name, right? This is just a test. So example, or like my thing works. And then here you need to do some code. Here you would do the thing where you have some initial balance, sorry, some account, right? And then you have some initial balance, probably. And then you would probably want to actually test your, like run your thing. And then you would want to do some assertions, some regular testing, right?
Just a quick note from experience of hacking on it, don't over-index on those two, right? They're just examples. You might need to do something on the Asset Hub first or whatever. It's like, this is not a template for the test you write. This is just like something to
so
get
you
started.
can of course, like, I mean, you are expected to create your own tests. You can just move this around if needed, right?
One of the useful things that the emulator comes with is also fund accounts, I think. So you don't have to do execute with, you can fund accounts directly.
Yeah, true. I would need to check if it works. Does it work from the get-go?
For me, it worked.
Okay, then it works. Then another thing you can do, which is Asset Hub West End, for example, you can do fund accounts. And then I believe you just give it a vector of tuples, no?
Yeah, it's a vector of tuples.
Okay, so you do a vector of I have no idea how to do the square brackets.
Look on the keyboard.
What?
Look on the keyboard.
Nice, thank you. So you would do, I'm not used to keyboards following their things. I'm used to changing the language on the keyboard. And now you would do the account, and then you would do the amount that you want, right? And then now you have the amount.
Native balance.
What?
It's the native balance.
Yeah, this would be only the native balance. Then if you want the foreign, like the foreign balance, you would need to do, execute with, and then for example, we need to add the snippets to Discord. We need to send them on Discord, or do what we did with the first assignment and just share a repo where we share snippets. But an example of how, someone asked an example of how to get a sovereign account. So it's okay if you find it and you hard code it. That was my original idea, that you just find it using the document that I mentioned, that I shared on the assignment MD. But one thing you can do is be like, okay, I want the sovereign account. Oh, sorry, yeah, because you need the sovereign account on the pallet. Well, you can actually do a test as well, right? Like, let me.
I think there's also a sovereign account thing.
Yeah,
on
there
the,
is.
on the emulator generated
Yes,
stuff. Right?
there is. So, for example, you can just get sov account, and here, come on, you can do asset hub West End, and I believe it's sovereign account ID of, and here you would give it a location. So here you would give it some location like this. And then you can print it, for example. And then you would be able to get the sovereign account, for example, right? Just need to give it a location, and then you get the account. I believe this is how it works. And then you can just put this account on your pallet. It's okay to just put it as a constant, because the sovereign account won't change. I mean it could change, but if it changes, it breaks everything. So more often than not, it won't change. You can just put it as a constant and use it. Another example of how you get like a foreign asset is if some chain has a foreign assets palette, like asset hub West End, you can just do asset hub West End. It started snooze 30 minutes. So you can do, to get the thing, you can do asset hub West End. This is all over the slides. So you just go to the palette, and you access the foreign assets palette. You can save this in an alias, so you don't need to type it all the time. And then you can do something like foreign assets as fungibles mutate or inspect. And then, for example, mint into, and this thing, because it's a foreign asset, it will require the asset ID, which is a location. And then it will require the account. And of course, the account, you can just do asset hub West End sender get. Okay. So those are a bunch of things that you might want to do. Like here you have examples of how to do them. So how do you get an account? We provide you with this sender and this receiver accounts. You can just use them, and you get accounts. If you want to just fund the native token, you can just use fund accounts. But you can also use the same thing as I did here with balances, right? You just go here, and you use balances instead. and that's perfectly fine. And then you can use the fungible straits, which you have already learned about, to mint or burn or whatever you want. Inspect, right? You can do another example is you can do inspect instead of mutate. And here you could check the balance of an account. This is also on the execution workshop. It's also on the slides. It's now here. I will send a snippet to Discord. Then, yeah, you would do this execute with to execute from the context of another chain. And then this is how you would get the sovereign account. Good. So is there any other question? If not, I will pass over to Alex and we can do the configuration thing. Yeah. And then we will use I will let this simmer. I will send these snippets to Discord, okay? And then I can and then you let this simmer, and if in the afternoon we will have more live coding. For now, we should maybe move on with the configuration.